Welcome to the module on thinking algorithmically. You have learned a lot so far in this course, and in this course we're going to take that next step on our logical thinking and our algorithmic thinking and actually talk about what an algorithm is and what a function is. They call them blocks in this programming language, and that's going to enable you to really take your programs up to the next step. So what is an algorithm specifically? Well, the definition comes from the Merriam-Webster dictionary, is that it's a process or a set of rules to be followed in calculations or other problem-solving operations. Any recipe that you follow is really an algorithm. It is a process or a set of rules. It has a set of steps. Put half a cup of this together with a quarter cup of this and a teaspoon of this and stir them all together in a specific way, and then you put it in the oven at a specific temperature. Well, if you don't follow the process or the steps, then you don't get the result that you expect. And if you've ever taken a science lab, chemistry, physics, biology, they all give you a set of prescriptions that you need to follow, basically, in order to achieve the outcome of the lab. So, for example, mix two things together in chemistry and you get to see a chemical reaction. If you mix the wrong things together, maybe something doesn't work the way you expect. Those are algorithms. Another example from the real world, if you've ever built any Lego sets come with instruction sets, and those instruction sets are examples of algorithms. If you've ever been inside a plane and flown anywhere, the pilots, they have a manual. And that manual has really got a lot of interesting algorithms in it, particularly what happens in an emergency. So if there's an emergency, they can flip to that page and they have a set of steps that they follow they can just calmly go through. And that's another example of an algorithm. Your programs are algorithms. The programs that you have written so far, they have step-by-step instructions for the computer to follow, and that's an example of an algorithm. In this module, we're going to talk about much more complicated algorithms and much more complicated programs. In this module, you will also be learning to think logically and strategically. That will be part of thinking algorithmically. And further, we will be looking at something called pseudocode, which is sort of code, but not really in any specific language. It enables you to actually just represent your ideas for the algorithm so that you can implement them. So by thinking about things at the highest level of abstraction, we can share ideas about how we can do something without focusing on how to do it in a specific language. So we can share the ideas back and forth. So for example, math is one way of expressing an algorithm in a language-independent manner. Let's consider, for example, Euclidean distance. That is, trying to calculate the distance from one place to another place. So the formula for that is that if you're trying to take the distance from one point to another point, you take the square root of the sum of the square differences between the two. That looks like a formula, and it is a formula, but it also tells you exactly how you can compute it in any language that you go to implement it. So you could do that in Snap if you wanted, or any other programming language if you're having a lot of fun learning programming. Another example, the Pythagorean Theorem tells you the length of any side of a triangle if you know the other two sides. It's a common one, a squared plus b squared equals c squared. Well, that looks like a formula, and it really is, but it also is another example of pseudocode and a way of expressing the idea in a language-independent manner. So math isn't the only way of expressing language-independent ideas of how to implement things. Consider, for example, giving somebody directions on how to draw a square. Well, you can go like this, you can go like this. They all work. You draw a square, you can just tell somebody to draw something with four equal sides that are all perpendicular to each other. Those all work, and we're going to talk about how to do that in code and in pseudocode in a future video. So why are we talking about algorithms and pseudocode? You might be thinking, this sounds sort of odd. I don't know, what do I need to use this for? Well, what you need to use it for is it's going to enable you to express much more complicated ideas and really enable you to step up your programs. So these algorithms enable you to think abstractly. And then furthermore, in this section, we're going to talk a lot about something called a function or a block, which is a way of thinking abstractly and reusing code. So that square example I gave you, instead of having to give it examples in your code to draw the square in every single different location that you need a square, you can just write one little chunk of code that draws a square, and then you just tell it where to draw that square. And that's so much simpler. Your code will be much more clean and much more elegant. I collected an example video from NSF that I want you to look at that will make it clear what the power of algorithms are. Let's get going on having fun thinking algorithmically.